So this is a walkthrough of paper 6, OCR calculator paper. Hiya. Okay, question 1. Alex draws a bar chart to show the age of the young people attending a club. Make one criticism. If you've noticed here, 5 is in this boundary and this boundary, so there's an overlap of ages. So the age groups overlap. Okay, next one, rearrange the formula to make U the subject. Here's my U. First of all, I'm going to make U squared the subject by taking 2AS off both sides. And then I'm going to square root both sides. Okay, you could have put a plus minus sign here. If you had done that, it would have been 5 and your 2 marks still. So a rocket accelerates at 90 meters per second squared and travels 270 kilometers. The rocket's final velocity is 8,000 meters per second. Use part A or otherwise to calculate the rocket's initial velocity. So here, I'm just checking to see if they would have given you that if you hadn't put U equals, which I didn't. Yeah, you do need U equals. So make sure you have got U equals there. Right, so the reason they've done this is because here our U is our initial velocity, and that's what we're working out in this question. So V is final velocity, 8,000. A is 90. And S is 270. But always check your units. Do we have consistent units here? Kilometers, meters. 1 kilometer is 1,000 meters. I need to times this by 1,000. Now we have our consistent units. So we know U equals the square root of V squared minus 2AS. I'm just going to pop it into the formula. And you should have 3,924 to the nearest meter per second. Okay, you will get all the marks for anything between 3,924 to 3,924.3. There you got a probability question, relative frequency. Bag contains 150 counters. Counters are either red or yellow. Riley picks up a counter from the bag, records its colour, and replaces it. They do this 9 times. Use Riley's results to work out how many red counters are likely to be in the bag. So we're going to look at his relative frequency from his results, which gives the amount of the probability of choosing a red counter 5 out of 9. Okay, so we want 5/9 of 150. So I've just timed this straight into my calculator. Just like that, which gives you 83.3 recurring, rounds to 83 red counters. Or they do give you the marks for 84 here. Okay, Ling uses the same bag of counters. Results to estimate the probability of using a red counter from the bag. Well, here we got 5, 10, 12 out of 20. That's the probability from Ling's results of choosing a red counter. Let's simplify that. I'm going to halve both of them. Halve them again. Why are they more likely to give a better estimate the probability of choosing a red counter from the bag than Riley's results? More trials, more results. Done the experiment more times. Something along those lines. So the time taken to complete a journey halves as the speed doubles. Sketch a graph. So hopefully you've noticed this as inverse proportion. Inverse proportion, one increases, the other decreases by the same proportion. If it was direct proportion, which if one increases one variable, the other increases by the same amount, it would look like this. But because it's inverse, your relationship is like that. Okay, it takes 40 minutes to fill a garden pond using water from 5 identical hose pipes. So 5 hose pipes takes 40 minutes. Assuming the rate of flow of water from each hose pipe is the same, work out how many minutes it would take to fill the same garden pond using 2 of these hose pipes. I'm going to work out for 1 hose pipe first. Obviously, it's going to take more time, so I'm going to times that by 5. 40 times 5 is 200 minutes. But we want to know for 2 hose pipes. So it took 1 hose pipe 200 minutes. Obviously, we divide that with half it because we've got 2 hose pipes doing the same job, 100 minutes. I'm going to have to describe how to do this one, I think. Because I don't have the facility to do this online. So we've got it's the same distance from A and B. So it's the same distance from these 2 points here. So what you should be doing is finding the perpendicular bisector. If you get your compass, you put your point in A and you open it so it's more than halfway along that line from A to B. And I draw from there a massive arc. Do not change the length of your compass now. Put your compass point in point B and just do the same thing. Draw another massive arc. And using a ruler, you can use, where does it say here? Using a ruler and compasses only. Then join those 2 points up using a ruler with a straight line. All those points along that line are exactly an equal distance between A and B. Okay, we also want this boat is the same distance from AB and BC. So it's the same distance from this line and this line. So what they're really asking you for here is the angle bisector, because it's something that's the same distance between 2 lines. So this time, what I'd like you to do is open up your compass. Doesn't matter how far you open it, really, as long as you don't change it once you've opened it. Put your compass point in B, because that's the point that's in both of those lines, and make an arc like this. Then put your compass point here, and you're going to make another arc, which should look something like that. And then put your compass point here, make another arc, which looks something like that. And then you extend and then you draw a line between this point and this point here. Of course, my lines aren't going to meet, so make sure you draw your lines long enough so that they do meet. You might get quite a different answer to me because I've not actually used a compass. I've just shown you what the construction line should look like, but the boat should be here where those 2 lines meet. Okay, question 6. At the end of each year, a driver records how many kilometres they have driven. In 2021, they drove 18% more than 2020. Let me just make a note of that. 2020, 18% more than 2021. In 2022, they drove 25% more than 2020. Let me just put that here. In 2022, they drove 3,500 kilometres. I can work out how many kilometres were driven in 2020 by reducing 3,500 by 25%. Explain why 2,625 is not the correct number of kilometres driven. So, if I had £100 and I increased it by 10%, you get 110, right? If I decreased 110 by 10%, take off £11 basically, you get 99 because you've got more once you've increased it. You can't go back like that. So you might have done this in a couple of different ways. So if we look from 2022 to 2020, so from 2020 to 2022, it's been increased by 25%. If you increase something by 25%, 100% at 125%, sorry, 100% at 25% is 125%. You're timesing it by 1.25 because that's the multiplier to get 3,500. So what you should be doing to work out the answer is dividing 3,000 by, so something along the lines of divide 3,500 by 1.25. That's why that one's not correct. Okay, let's just have a look at if there are any other answers that they would have considered fine for this, for the mark. So they should have divided by 1.25 or multiplied by 0.8 or 2,000. Oh, you could have said 2,625 increased by 25% is 3,281.25, not 3,500. Okay, calculate the number of kilometres driven in 2021. So let's actually do that. Let's work out 2020 first by dividing 3,500 by 1.25. In 2022, number of kilometres was 2,800. We want 2021 though, so we need to increase this by 18%. I'm going to use multipliers. You might use it a different way, but if we've got 100% of it and we increase it by 18%, we've got 118%. As a decimal is 1.18, so we're going to times it by 1.18. Which gives you 3,304 kilometres. Diagram shows the graph of y equals kx minus x squared plus 2. We've got a quadratic graph here with negative x squared, which is why it's that way and not that way. Show that k is equal to 3. So I'm going to choose a point in my curve where I can get some nice coordinates from. I might choose this one here. Can you see 1, 4? That, so the coordinate 1, 4 lies on my curve. X is 1, y is 4. So I'm going to substitute that into this equation here because I know those coordinates lie in the line. So 4 equals k times 1, which is k, minus 1 squared plus 2. See, I've just put it here. K times 1, 1 squared is 1. So 4 equals k minus 1 plus 2. Could do this a few different ways. I'm going to take 2 off both sides first. Add 1 to both sides to give you 3 is equal to k, or k is equal to 3. So I've shown that there. Use the graph to solve 3x minus x squared plus 2 equals 3. So this graph here is equal to 3. So you need a straight line across here, drawn with a ruler. And you need the x values. I'll give you that answer. Oops. So 2.6 is one of your answers, or 0.1 to 0.4. Taylor designs a logo using isosceles triangles joined at the point P. This is Taylor's design. The completed design will have a rotational symmetry of 60 around point P. So like it fits inside itself 60 times. So I'm just thinking already, if it's got a rotational symmetry of order 60, around a point's 360 degrees, 360 divided by 60 is 6. So this angle here would be 6, which is the same as this angle here. And I'm also thinking, right, I can see a right angle triangle there. So I'm thinking this is SOHCAHTOA. So that's 6 degrees. We've got our X here is our opposite. We want to know the height. B is 40, obviously because I've cut it in half to make a right angle triangle, so this is 20. Got opposite and adjacent, so it's tan. So tan theta, in this case, is 6, equals opposite over adjacent, times both sides by 20. X is 2.1 to 1 decimal place. On Heidi's bookcase, the ratio of fiction to non-fiction books is 2 to 3. Heidi removes 2 fiction books from the bookcase. The ratio of fiction to non-fiction books is then 5 to 8. So it's the non-fiction books. Right, hang on, let me line this up. So I've got non-fiction books together. Again, you might have done this a slightly different way to me. So I'm going to make non-fiction the same. So I'll be thinking, what's the lowest common multiple of 3 and 8? It's 24. So I'm going to times that top ratio by 8. I'm going to times this bottom ratio by 3. Times this by 8, we get 16 fiction, 24 non-fiction. 3 times 8 is 24, 3 times 5 is 15. Okay, now if you see it like this, so 16, I know that's fiction, the non-fiction is 24. This is taking one book out, isn't it? We're taking out fiction books. You've only taken out one fiction book there. Let me double everything. Let me double this entire ratio to get 32 to 48 to 30. Okay, now can you see if we take out 2 of these non-fiction books to get from 32 to 30? So how many books are left on the bookcase in total? Well, this is what we have in the end when our 2 books are taken out. How many books do we have in total? 48 plus 30 is 78 for your 4 marks. Show that 95 is not a prime number. Remember, you've got your calculator here. So we need to show that 95 is more than 2 factors. 95 divided by 5 is 19. 19 is a factor, 5 is a factor, 1 is a factor, 95 is a factor. So it has more than 2 factors. A prime number has exactly 2 factors. And you may have been shown this next question in a few different ways. So I know 2000, these are the prime factors for 2000 and 8750. I'm going to put mine in a Venn diagram. You may have been shown like this. This circle represents 2000. This circle represents 8750. What's common to them both here? Well, we've got 1, 2 here and 3 2s here. So 1, 2 is common to them both. We've got 3 5s, 4 5s, got 3 5s is common to them both. Now, if you just look, to get 2000s, it's 2 to the power 4 times 5 cubed. This circle represents 2000. You've got 5 cubed times 2. We need 3 more 2s here. And on this side for 8750, we've got 3 5s, a 2, so we need another 5 and a 7. Highest common factor is anything common to them both multiplied together. So it's 2 times 5 cubed, which they probably will give you the answer for. Oh no, you do actually need to work it out. You'd only get 1 mark for that. 2 times 5 to the power 3 is 250 for your 2 marks. Okay, right, 2 times 10 to the power 12 is a product of prime factors. The reason this is not in prime factors at the moment is this 10's not a prime number. If I make 10 into a product of its prime factors, it's 2 times 5. So I need to power 12 both of these things in the brackets, both these numbers in the brackets, which simplifies as 2 to the power 12 times 2 is 2 to the power 13 times 5 to the power 12. We know that SR is 6 centimeters longer than PQ. I'm going to call this X because this is 6 centimeters longer. I'm going to call it X plus 6. How do you find the area of a trapezium? You probably will be given this in your formula book. Half times A plus B times H equals A. That is the area. So A is X. These are our parallel sides, the A and the B. Add X plus 6 times 10. Half times 10 is 5. X plus X is 2X plus 6. I'm going to multiply out those brackets. That's an expression, an equation for the area, but write a simplified expression for the length PQ, or PQ is X in terms of A. So it's saying that it wants you to make X a subject there. So let's get rid of this 30 by taking 30 off both sides. And now divide both sides by 10. That answer there for your 5 marks. Box contains 200 matches, correct the nearest 10 matches, error interval. So this is kind of like upper bounds, lower bounds, isn't it? It's been to the nearest 10 matches, half of 10 is 5, so 195 is your lower bound. Now remember here, the matches just come in whole numbers. We're not part of a match. So 204, because of this, so usually for upper bound, you say 205, don't you? But because it's less than or equal to, we can only get a whole number of matches, we're going to put 204 there. The box is a cuboid, 7 centimeters to the nearest centimeter. I'm just going to start getting my upper bounds and lower bounds for these. 7.5, 6.5. 5 centimeters for the width to the nearest centimetre, so that'd be 5.5 and 4.5. I'm going upper bound, then lower bound. And the volume, 248 to the nearest centimetre cubed, 248.5, 247.5. Show that the smallest possible height of the box is 6 centimetres. Volume equals length times width times height, right? Let me deal with this multiplication first. So we want the smallest possible height. Can you see we're going to be doing a division in the end because you're going to know what V is and you're going to have to divide it by length times width. So when you do a division, to get the smallest possible value, you need the lower bound divided by the upper bound. So we're going to need a lower bound for the volume, which is 247.5. We're going to need an upper bound for your length times width. So we need your highest length and your highest width. Multiply those together. And divide both sides by 41.25. Hopefully we're going to get 6. Yes. Histogram question. 18 members run less than 20 kilometers. So what you need to remember for your histogram, the frequency, the area of your bar. The area represents the frequency. We've got 18 members. So that's the area of your bar. So what's our frequency density? What would you multiply 20 by to get 18? Let's do 18 divided by 20 is 0.9. So that gives us a height. That means this value here will be 0.9. Work out the number of members who run more than 30 kilometers. So we need the area of this bar and the area of this bar here. So we need to kind of work out a scale for this frequency density. So I'm thinking that's going to be 1 there. Each like couple of boxes is 0.1. Who would have 1? So what would this be here? 3. So 10 times 3 is 30. Your base is 40 here. What's your height? 0.3. 0.3 times 40 gives you 12. Sorry, didn't think that answer looked right. That's 2, isn't it? Of course. Right, that's 1.52. This is not 30 at all. It's 20. 20 had 12, 32. Finley says, I estimated the range. I subtracted the smallest possible value from the largest possible value. 80 take away 0 is 80 kilometres. Explain why Finley's method is likely to overestimate the true value. So these 12 members, we don't know the distance that they actually ran between 40 and 80. It could be anywhere in this boundary. Unlikely to be 80. So how are we going to word this? Unlikely the largest value will be 80. You could have had longest distance could be anywhere between 40 and 80. Unlikely the smallest value would be 0. Shortest distance could be anywhere between 0 and 20, except exact distances are not known. The data is in groups. The box plot shows the distribution of the distance run by each member of the running club during July. This is July, December. Got this information, make 2 comparisons. So what's the median in July? The median is here from this box plot. 26. So median equals 26 kilometres for July. So in July, the distances were on average lower. In July, distances ran were lower. Because we've been given the interquartile range for December, let's compare the interquartile range. The interquartile range is upper quartile minus lower quartile. Upper quartile is 54. Lower quartile is 18. 54 take away 18 is 36. So in December, the interquartile range is lower. So it means the distances ran in July were more varied because it's got a higher interquartile range. So distances in July more varied. Because higher interquartile range. Okay, what else did they allow? July distances were more varied. Yeah, that's it really. Okay, so draw a plan view of the pyramid. A plan view is the view from the top. You looked at a pyramid from the top, it would look a bit like it would be a square really. We've got 20 centimetres, 1 centimetre represents 20 centimetres. 20 divided by 4 is 5. So we need a square 5 by 5. 5 squares by 5 squares. Got to also allow for the fact that when you're looking from above, you're going to kind of see these lines of these diagonals, but they're going to seem flat. So you need to join your diagonals together. Be 2 marks for that question. Calculate the volume of the pyramid. Given the volume for this, it's a third area of base times perpendicular height. Area of the base is 20 by 20. Times the perpendicular height. Problem is, we don't have a perpendicular height, which is this one. But hopefully you've noticed you have a right angle triangle. Let me draw this here. Now with our right angle triangle, that's unknown and that's unknown. We've got that as 14.5, so I need to find another right angle triangle. Well, since the base is a square, you have actually got a right angle triangle here too. So I'm going to use Pythagoras first of all to get my hypotenuse. A squared plus b squared equals c squared. So square root of 20 squared plus 20 squared. 28.3, 28.28. Half of that though, because we want from here, from O to A. Divide that by 2, we get 14.14. Hypotenuse is 14.5. We have the hypotenuse, one of the shorter sides, so it's the square root of 14.5 squared minus 14.14 squared. So we have found our height to be 3.21. So what's a third? Times 20 by 20 times 3.21 gives you 428. Right, what have we got? 426.6 to 427. So let me see what's gone wrong here. Maybe I rounded too early. Let's just have a look at my answers up here. Square root of 20 squared plus 20 squared. I'm going to carry forward this answer, right? So I've got 28.28. I'm going to divide it by 2. Gives 14.14. When I put it into my calculator, I'm going to do the square root of 14.5 squared minus the answer squared. Gives me 3.2. Just give you 400. I don't know what I must have typed in something different before. Oh, let me just put 2 1. All right, okay. So it just, yes. So because I rounded values before, I didn't use my exact answer. I think. Let me just check that, sorry. Unless I rounded it correctly, it definitely gives me 3.201. So just use 3.2. If I had have got 3.21 before, maybe I just rounded too early in one of these calculations. So if we type that in your calculator, we get 426.6 or 427. Similar shapes for area and volume, perhaps, where I've read the question. Small bottle holds 0.5 litres, which is a volume. Got a height of 35 centimetres, which is a length. We've got another volume here. Okay, so let's get the scale factor for volume. So 2 divided by 0.5 is 4. How do we get the scale factor for length? We cube root that 4. .587. Calculate the height of the larger bottle. We know the smaller bottle is 35, so we need to times it by that 1.587. 55.6. So 55.5 to 55.6 for your answer. Or 56. Price of a seat on a flight P is given by P equals 49 times 1.009 power N. N is the number of seats already sold on this flight. Write down the percentage increase in price of the second seat sold compared to the first seat sold. We know this is the multiplier, isn't it? When we're finding a multiplier, we add the percentage to 100% and then divide by 100. I'm going to multiply that by 100 first. I can tell it's 9 by looking at it, but I want to give you a method of doing it. So let's say the increase was 13%. You'd add 100 to it, and then you divide it by 100. What are we going to do? This 1.009, we're going to go backwards. So we'll times it by 100 and take off 100. So 1.009 times by 100, take off 100. Yes, gives you 0.9%. Show that the price of the 40th seat sold is less than £70. Well, this formula works for the number of seats already sold on the flight. If you're buying the 40th seat, N would be 39. So we need 49 times 1.009 to the power 39. Which gives you 69.49, which is less than £70. The kth term of a sequence r to the power k, where r cannot equal 0, the sixth term is equal to 3 times the second term. So we've got our first term, second term, third term, fourth term, fifth term, sixth term. The sixth term is equal to 3 times the second term. Okay, so I'm going to divide both sides by r squared. Let's find the fourth root of 3. 1.31. Oh, to 3 decimal places, 1.316. I can tell, hopefully you've revised your circle geometry. I can tell that this is the equation of a circle. It's going to go through the origin, isn't it? Because it's the formula is like x minus a all squared, add y minus b all squared. I don't know if it goes into that much depth for GCSE, but hopefully you can tell this circle goes through the origin, so through 0, 0. So it's a circle. Just recognising that type of equation gives a circle. And it's x squared plus y squared equals r squared. Circle with centre 0, 0. If it wasn't 0, 0, it would have some kind of equation with a number following your x and your y. And radius square root 20. Which you might have as 4.47. So the graph of y equals 3x plus 10 intersects this circle at 2 points. Use an algebraic method to work out the coordinates of the 2 points. I'm going to substitute this into here, so I've got an equation just in terms of x. Multiply out these brackets first of all. Don't forget, this actually means 3x plus 10 times 3x plus 10. 10 times 3 is 30x. Going to simplify it to give 60x. See, now we've got a quadratic equation. I'm going to make equal to 0, bring everything over to the left-hand side. X squared plus 9 squared is 10 squared. Minus 10 from both sides. No, that should be 20 though, shouldn't it? Sorry. minus 20 from both sides. Now my equation is equal to 0. I'm going to divide through by 10 to make it much easier. Let me factorise it. Two numbers that multiply to get 8, add to get 6 are 4 and 2. X is equal to either minus 4 or minus 2. What are my corresponding y values? Well, I know y is equal to 3x plus 10. I sub in this x value into the equation. 3 times minus 4 plus 10 is minus 2. So x is minus 4, y is minus 2. I'm going to sub in my minus 2. So 3 times minus 2 plus 10 is 4. Those are your two coordinate values. Simplify inserts. I'm going to put it under the same surd. 11 times 22 is 242. I want to show that this is equal to this 11 root 2. Square numbers that divide into 242, so it's 121. I can rewrite this as 121 times 2. And split it. Root 121 times root 2. Root 121 is 11, so it's 11 root 2. I'm going to rationalise the denominator here. How do we rationalise the denominator? We need to multiply it by 13 minus root 22. Multiply out these brackets at the top. 13 times root 11 is just 13 root 11. Root 11 times root 22. What did we work that out here? Is 11 root 2. Multiply out my denominator. 13 times 13 is 169. And then we'd have minus 13 root 22 plus 13 root 22, which cancels to make 0. Minus root 22 times root 22 is just 22. So obviously these would cancel to make 0. So we've got 169 minus 22, which is 147. So what are A and B? A is 13 and B is 147. Write this in that completed the square version. I'm going to expand my brackets first. 2x squared plus 8x minus 5x minus 20. Simplify. We need to complete the square with that next. So to complete the square, so that should be minus 5x here. To complete the square, we need the coefficient of x squared to be 1. It's 2 at the moment. I'm just going to divide through by 2 and factorise it. 3 divided by 2 is 1.5. If I expanded these brackets here, I get 2x squared plus 3x minus 20. Now I'm going to complete my square with this bit. Half of 1.5 is 0.75. If I multiply the brackets out there, so x plus 0.5 squared, I'd create 0.75 times 0.75 that I don't want. So I'm going to subtract off 0.75 squared, which is 0.5625. And don't forget about this minus 20. I'm going to then expand my brackets, multiply this by 2 times this minus 0.625 times 2. And then minus 20. Minus 1.125, take away 20 is minus 21.125. You may have it in fraction form, in which case it would be Well, 3/4 inside your first bracket and 169 over 8 for that number on the outside. Charlie, Deb and Eve will attempt to sketch the graph. So, whose graph sketch is most accurate? The whole point of completing the square is to work out the minimum or maximum value of the graph. I know this is a curve here, which is the same one as this one here. It's a curve with a positive x squared, so I know it's this way round. All of those are that way round, so it could be either still. The minimum point is at 0.75. No, is it minus 0.75? You need the opposite sign here for your x value. And minus 21.125. Those are the coordinates of your minimum point, which cannot be Dev's sketch because you've got a positive x value here. So it could either be Charlie's or Eve's. Now, when I expanded these brackets, I got, let's have a look, 2x squared plus 3x minus 20. That shows it crosses your y-axis at negative 20. So it's got to be Charlie's. Minimum, and because y-intercept is negative 20 and min coordinates are minus 0.75 minus 21.25. Okay, thanks for listening to my revision recording. If you weren't sure on any of those topics, if you just leave me a comment in the on the YouTube, just to say like which paper it was and the question number, and I can send you in the right direction to watch some revision videos on that topic. Okay, thank you.